diagram shows a car travelling at a constant velocity along a horizontal road. Draw and label arrows on the diagram representing the forces acting on the car. The thing we need to bring into for this question is Newton's third law, which I'm just going to recap here, which states that for every force there is an equal and opposite force. Now what that means is if you say push against a wall with 500 Newton force, the wall will push back with exactly the same force against you. And if the wall doesn't move, then the overall resultant force will be zero. The wall will neither fall down and neither will you. So the forces are equal and opposite. So when it comes to drawing forces onto diagrams such as this, you have to think about, if you are given one force, you must mark in the opposing force in literally the opposite direction. So what we've got already for us is the driving force, which it looks as if they've marked it out as V, which means there must be a frictional force acting horizontally in the opposite direction to the left. Let's call that F. And then we have the weight of the car, which is vertically downwards, which means there must be some upwards force opposing that weight. And that is going to come through the contact of the wheels against the road. So there will be a reaction force, R1 there, and the other one, R2. And R1 plus R2 will be equal to the weight acting downwards. So those are the forces drawn in. Part 2. Referring to Newton's laws of motion, explain why the car is travelling at a constant velocity. Now this brings in the first law, which states that for a car or an object moving at constant speed, there cannot be a resultant force. So the driving force must be equal to any frictional forces. Driving force is equal to the frictional force. So when that happens, there cannot be any acceleration or deceleration. So therefore the resultant force, which is the difference between these two forces, is going to be equal to 0. So the car has an effective power output of 18 kilowatts and is travelling at a constant velocity of 10 meters per second. Show that the resistive force is acting is 1800 newtons. So first of all, I want to turn kilowatts into watts, just in a base form. So there is 1,000 watts in a kilowatt. That will become 18,000 watts. And just to recap, a watt is equal to 1 joule of energy transferred per second. What is the formula relating power, force and speed? It is power equals F times V. So I need to rearrange to get F. So F equals P divided by V. Substituting in 18,000 divided by the velocity, which is 10, gives 1,800 newtons. So remember, watts is the unit for power and it just represents energy transfer per unit time. Say you had a hairdryer which was 800 watts. That means 800 joules of electrical energy would be turned into heat energy and other forms every second. The total resistive force consists of two components. One of these is a frictional force, which is constant at 250, and the other is air resistance, which is proportional to the square of the car's speed. Right, before I go any further, I'm going to make a little diagram of this, just to simplify the text there. So we have the driving force, V, using the letters from the top. And then the frictional force is made up of two bits. It's the 250, which is fixed. And then we have the air resistance. Well, let's call that A. Calculate the force of air resistance when the car is travelling at 10. This one isn't too difficult because from the previous part of the question, we know that the total resistive force when the car is 10 meters per second speed is 1800. We can substitute that in. 1800 is equal to 250 plus the air resistance, which means rearranging 1800 minus 250 gives A equals 1550 newtons. So the air resistance in this particular case is 1550. Okay, the force of air resistance when the car is traveling at 20 meters per second. Now, what I need to do here is bring in a bit of grade 10 GCSE maths involving proportionality. So if something is directly proportional, that means when one quantity doubles, the other doubles as well. Or when one quantity triples, the other triples as well. In other words, they go up by the same amount. We can write this where F, the frictional force, air resistance F, is directly proportional to the square of the speed. So the proportionality symbol is that little sort of alpha symbol there, V squared. Then to turn it into a regular equation, F equals K V squared, where K is the proportionality constant. So I need to work that out first before I can work out part 2. K equals F over V squared. Now I can use the air resistance from the first bit, which is 1550, because I know the speed at which that air resistance happens, and it's 10 meters per second. So 10 squared is 100. So 1550 divide 10 squared, so in other words divide 100, gives us 15.5. So the proportionality constant for the air resistance and the square of the car's speed is 15.5. So now I can work out what the air resistance is at 20 meters per second. So using the same equation, F equals K V squared. F equals 15.5 times 20 squared, which is 400, gives us an answer of 6200 newtons for the air resistance. Okay, finally, the effective power output required to maintain a constant speed of 20 meters per second in a horizontal road. Constant speed, driving force, must be equal to the total frictional force. Let's do a little diagram. We have the forwards force V, we have the 250 fixed part, and the air resistance at 20 meters per second is 6200. So therefore, the total friction is 6200 plus 250 gives us 6450. So that's the total frictional force. Now, why do I need to know this? Well, if something's moving at constant speed, as I said previously, the driving force, which we've called V in this case, must be equal to the total frictional force. So therefore, this is also 6450. And then finally, we can bring in the equation which we used in part B here, which is power is equal to force times velocity. P equals 6450 times the velocity, which is 20, gives an answer of, or in other words, 129 kilowatts. As you can see, this question was certainly more tricky than the previous part. Otherwise, I hope this was helpful, and I will see you in the next one.